What's up, y'all? We're on number 61. I had to do a cut because I screwed something up, so I figured I'd actually fix it this time instead of going with it and fixing it there. So what the problem is asking is to do a logarithmic model of this data. So we do it the same way we do it, stat, edit, and then stat calc. Go down to it's ln reg. But when I did that first, a lot of times we'll put 0 here for the first year and then add accordingly as we go down. That usually makes the numbers come out a little bit better. When I did that and I put 0 here, it gave me an error because you can't take the natural log of 0. That doesn't work. So we have to actually use these numbers. So when you do this problem, the regression, put in those actual numbers, and you want to find the year when it's going to get to 1,500. Okay, logarithmic regression, yeah, okay. So go ahead and try that out, and I will get back with you in a minute. Okay, minute's up. So I went ahead and I put the data in here into my calculator, and you can see that last number, when I put that in, that is in scientific notation. It was too big to fit in the field, so there's the actual number, and that is correct. So we'll go to stat calc. Whoops. There we go, number 9, natural log regression. Remember, natural log is just a vertical stretch of any other logarithm, so this is okay that we're doing natural log here. And I'm going to put, well, I think I just did this a minute ago, right? Look at that there. But I'm going to put it in y1. I'm going to put it in y1. That'll make it a little bit easier for me. And is that still the same thing? No, that's different, okay? So this is what it should be, and under my y equals, I put it in under y1. And I was working on this a little bit a second ago, and I already have y2 equals 1,500,000. So we can see where these intersect each other. I'm going to go up to plot 1 to assist me to get to the right part of the window and plot those points. Because, the default window is 10 by 10, and that's nowhere near any of my information. So let's turn on plot 1 and do zoom stat. So zoom, I believe that's the one at the bottom. No, zoom stat is next to the bottom. And that will plot the points and give me a nice window to go by there. Okay, it says it's logarithmic. That basically looks like a straight line, though. I want to go over to when the population is 1,500. So I'm going to adjust my window and go up to 1,500. And go up to, 1.5 million. And then I'll also have to adjust my x-axis as well, but I want to get an idea of about where I'm at. Okay, so there's the line at the top of the screen. That's the line I want to get up to. So let's adjust the x maximum now to get over a little bit further. So the window, the x maximum, let's go up to, 2030. Okay, there's the logarithm. There's the line, and that's where they intersect. So let's find that intersection by using calc intersect. The first curve, the second curve is y2. I'm looking up here for that curve. And then I guess, and it'll actually save some, let me see. So if you hit second and then over, that'll make it jump a little bit faster. You can get across that line a little bit faster. And let's get kind of close there. That'll make the calculation come a little bit quicker. So 2022, 0.998. So let's say 2023 is the year that they intersect. Let me show you a different way to solve the same problem using the solver. It'll just take a second. Math down to solver. Okay, I want to set no when 0, it always has to be 0 equals. So I want to know when y1 equals 1.5 million. So I want 0 to equal function y minus, 15, and 1, 2, 3, 4, 5. Okay, so there's my equation. And look, the calculator had x from the other problem. So it kept the x in there. But the solver is pretty handy. It looks in function y1 and grabs the variables out of it to put there. So let's say that that wasn't there, even though it was. My last value is at 2,000, so let's put that in there for our initial guess. And I'm going to go ahead and alpha, enter. And then it's going to work on that, and it'll give us the number there as well. So that was actually a little bit quicker to do it that way instead of using the graph. So this solver, we haven't used it very much, but it's very quick and powerful, especially when there's only one answer. and especially when we only need an approximation. When we don't need an exact answer, and when there's only one answer, this is really handy. This left-right thing just tells us how far off your answer is, but this is as close as an approximation as the calculator can give. That's why that's 0. The boundary, you can set the boundary of the answers, but this is all numbers the calculator can handle. The calculator can go from negative 10 to the 99th power to positive 10 to the 99th power. If I just wanted to say positive numbers, I would make this 0 here. So if I did that, now the calculator would only look for non-negative solutions. Okay, so the boundaries, that's telling it, that's kind of giving the calculator an idea of eliminating some answers, if that will be appropriate. So that's just another way to do it in the solver. Your assignment, which is what you've been waiting for, continue working on this page. Let's see, 41 to 68. 3m minus 1. That means 1 less than the multiples of 3, which 41 is 41, 44, 47. Start at 41 and count up by 3. So the next problem will be 44. And stop, do 68, and then stop.